Hello. For this project, we are going to be covering San Francisco's geological history as well as the tectonic plates. So sit back, relax, and enjoy the ride because I'm your host, Lucian Nakazato Patterson. First, we would like to talk about Pangea when all the continents were together and made one big continent called a supercontinent. Out of nowhere, multiple mid-oceanic ridges formed in the continents. These mid-oceanic ridges moved the oceanic crust by 5 centimeters every year. The plate movements can happen in 3 different ways. These are the 3 different ways. The first plate movement is called plate motion and the subduction process. We are going to be showing the Farallon plates and why San Francisco no longer subducts. We will also be showing the different ways and types of subduction, such as divergent, transform, and convergent. Subduction is the process in which 2 tectonic plates collide and one is pushed under the other into the mantle of the Earth. The friction of these tectonic plates thus creates earthquakes. The reason why San Francisco Bay is so prone to earthquakes is because the San Andreas Fault is right on San Francisco. The transform fault was originally horizontal between the Farallon Plate and the Pacific Farallon Plate, but then when they collided with the land, the subduction stopped and the transform fault began to expand and extend vertically, reaching up to San Francisco. This is why now we call SFA. Now that you know what subduction is, how it works, and how it ties into the San Francisco geological history, I believe that it is now time to talk about the other types of ways that tectonic plates move and interact with each other. Yes, that is correct. I am talking about divergent, convergent, and transvergent plate boundaries. Well, for starters, there are 2 types of convergent plate boundaries. One of them is subduction in terms that an oceanic crust interacts with a continental crust, and since the oceanic crust is more dense, it sinks under the continental crust and into the Earth's mantle, where it remelts into magma. The other type of subduction is when 2 continental crusts interact with each other, and since they are both the same density, none of them sink under the other, so thus they collide into each other and create huge mountains, such as the Himalayas. The second plate boundary is called divergent plate boundaries, and it is where 2 tectonic plates move away from each other. This then exposes magma to the air/ocean to be cooled and create new rock. And finally, the last but certainly not least tectonic plate boundary is called transvergent, and it occurs when 2 tectonic plates move side to side to each other. This can create earthquakes such like subduction. So, now you know all of the tectonic plate boundaries. When the Farallon Plate collided with the North American Plate, the San Andreas Fault was formed, which then thus created a transform plate. The fault was created because the mid-oceanic ridge on the Farallon Plate tried to subduct under the North American Plate. The mid-oceanic ridge could not fit inside the subduction zone. Thus, subduction stopped. The reason why the Farallon Plate subducted underneath the North American Plate is because it was less dense. 30 million years ago, this causes a lot of volcanicism toward the east side. A transform fault is when 2 plates rub on each other in different directions. This then broke down the plate until it was completely gone. North America covers the Farallon Plate, causing a massive crucial extension. Enough about the east side. Back to San Francisco. The first rock that came to San Francisco was the sedimentary rock named chert. Chert is non-colliated and takes around 200 million years to form. In order to create chert, it takes 1,000 years only to form 1 millimeter. Chert forms from radiolaria at the bottom of the ocean. The process that can happen to create chert is called turpentine. When a major earthquake or storm happens once every 1,000 years, the radiolarium goes down under the subduction zone and because of its high density falls first. And then the other sediments fall on top of the radiolarium. Basalt came from the mid-oceanic ridge and around 200 to 80 million years ago found itself to be at the bottom of the San Francisco Bay. It was formed when sand and mud and the other sediments settled. The last but certainly not least is serpentine. Serpentine is a metamorphic rock created from basalt that had pressure applied to it when it was heated. Thank you all so much for listening to our presentation. My name is Lucian Nakazato Patterson, and as of right now, I am sweating a lot because I am underneath the covers to create insulation. I will see you all in the next episode. Thank you all so much.